Good evening, I'm Katie Couric, and this is 7-Minute News. I hope you enjoyed our segment last night on the World Cup coverage. Tonight we are going to take a look into the Hurricane Katrina, the Category 5 hurricane that destroyed the South. First, we have Glenn Smith, the great-great-grandson of Adam Smith, who will explain Hurricane Katrina and how it affected supply and demand in the lumber and oil prices.
Alright, good evening ladies and gentlemen. I came all the way in from Scotland because my great-great-grandpa, Adam Smith, is a famous Scottish economist. He instilled on me a lot of great things about economics. So I'm going to explain how Hurricane Katrina had a bit of an impact on the US market. Right, so you've got the supply of lumber in the US and the demand of lumber in the US. Now what happened is, Hurricane Katrina caused 1.3 million acres of forest was destroyed. 20% of the labour market was destroyed, and overall, the $50 billion loss to the forest industry. Now what happened is, the supply of lumber decreased, and with that, shifted the supply curve down a bit, right? Now, in order to rebuild the area, they had to get a little bit more of the people were looking for more lumber, so demand increased as well. Right, so the demand curve also switched up a bit. Right, I draw a little bit of an arrow for the demand curve changing. And what it does is your equilibrium price goes from here and it moved quite up to here. So your new equilibrium price rose a wee bit. Right, so what do we learn? That the supply curve shifted because there was a lack of resources, and the demand curve shifted because consumers' taste increased and they needed more. Right, so now that we've seen the shifts in the demand curve for the lumber market, let's take a wee bit of a look at the oil market. Right, so we got the supply of oil, pretty standard, you know, a little bit of a line right to this, good nice. Right, and we got the demand for oil. Right, so beforehand we had the equilibrium quantity and the equilibrium price right here. Right, see that line across there, the equilibrium price is great. So what happened is, during Hurricane Katrina, 30 oil platforms were destroyed and 9 refineries were closed, which caused a total loss of 25% of the oil production in the area due to Hurricane Katrina. So very similar to the market for the lumber, the supply of oil decreased because of the effects of Hurricane Katrina. Alright, there we go. So supply decreased, right. So what also happened is people were demanding more gas and oil to dry down and power machineries to rebuild the area. So what happened is, the demand curve also shifted up. Bloody brilliant, look at that. So, very similar to like what we had in the lumber market, is the equilibrium quantity stayed the same, and the equilibrium price moved a bit up as well. So we can see that Hurricane Katrina had very large effects on the market for both oil and lumber. And overall, it was guessed that the estimated damages for Hurricane Katrina was $81 billion. Right, it's a lot of money, Alright, and also, the economic impact on just Louisiana and Mississippi was estimated at $150 billion. I don't know about you, that's quite a lot of money. Alright, for Glenn Smith, I am signing out tonight. Thank you very much.
Thank you, Glenn Smith. We are very appreciative you came all the way from Scotland to share your wealth of knowledge. I'm sure your granddad, Adam Smith, the Scottish founder of economics, would be very proud. Now we will go over to Joe Barbary, who is our well-known local meteorologist, who will explain the massive storm surge that Hurricane Katrina possessed that tore through the South.
Okay, what we're going to be talking about today is the Hurricane Katrina. Now this is the hurricane right here, and what happens is all this wind comes in from the ocean here, and it goes upwards through the eye of the hurricane, and here's the two dangerous things that happen is, first of all this wind is going to push the water level up. So this water level here is going to slowly come up by the house. And then what's going to happen, since there's a low pressure, it's going to cause a little bit of a bubble there, and this bubble can be 50 miles wide. And then what happens is this storm is going to move this way towards the houses, and this bubble here is going to become a storm surge, and all this water is going to come up and just smash your houses. Remember, if you can get in a boat or something. So my name is Joe Barbary, and I can be your meteorologist too.
Thank you, Joe Barbary. I had no idea how much the massive wind speed of Hurricane Katrina could really destroy. Now I have a segment from a previous interview I conducted with Michelle Kroll, the Senior Structural Engineer of the Army. She walks me through the new structural design of the levee and gates. Thank you for coming, Michelle. Now explain to me how these new designs are going to be more sufficient and how they're going to be different from the older ones.
Well, Katie, what we have is it's a surge barrier, and there's going to be one gate and one levee, and the gate will be connected to land. And what is going to happen is this gate that I'm going to show you in a few minutes is going to be by the Mississippi River Gulf Outlet, and it's supposed to be finished by 2011 is what our hopes are, and we're still on track. Right now we're trying to get an individual environmental report out to the public to get some comments and see how they feel about it. But with this new gate that we have here, what we will be doing is, as you can see, this is where it connects to land. Those are part of the levees. This is our gate right here. It's called the Seabrook Gate. And what we have is, to make it nice and sturdy, as you can see right here, it's rounded. That will allow for when the flood starts to come in, it'll allow for a little bit of leeway, and the water can flow around the circle. That's why we have that half circle right there. And underneath, if you notice, we have triangles right here. Here's one that I'll bring out for you. And the reason we put triangles on the bottom is they're the sturdiest structure, because we will have this leg, and then our third leg is going to be that bottom. All of these triangles will be the same size, so they'll be congruent triangles. And the reason that the triangles are on the bottom instead of, say, a rectangle or a square is if you had a rectangle or square, this top part would be able to shift when the water and the current started to flow through. So these triangles will help to make sure that that stays sturdy and nice and strong so that the floodgates can work properly. Do you have any questions?
Are these levees going to be capable to handle the strong amount of water that came in with Katrina, something that large?
We do believe so. That's what we planned for, and we'll keep our fingers crossed that that's what works.
All right, thank you.
All right, I'm Michelle Kroll. God bless.
I'd like to thank Glenn Smith, Joe Barbary, and Michelle Kroll for joining us tonight and helping us develop a better understanding of Hurricane Katrina. This is 7 Minute News. I'm Katie Couric, and thanks for flying by.